Ever get the feeling like the universe is hiding something? Something really, really big.
Well, I mean, it kind of is, right? I mean,
Yeah,
that's what we're here to talk about.
right, exactly. And this time it's literally massive. We're talking black holes, but like way tinier. So, in this deep dive, we're tackling something called primordial black holes. And get this, they might be the missing link to finally figuring out what dark matter is actually made of. We had this incredible article on, well, it was about these primordial black holes, think it micro-sized black holes, and they've been potentially zipping around since, well, practically forever, the Big Bang.
Yeah, it's a fascinating area of study because it really challenges some long-held assumptions we have, in physics and cosmology. What we're learning about these potential primordial black holes
Mm-hmm.
could totally rewrite our understanding of, well, everything, dark matter, and even how the universe itself evolved.
Okay, so before we get too far into it, let's talk about what makes these primordial black holes different from the regular kind. Because I thought black holes were, formed when giant stars die.
Right, yeah. So that's true, but only for certain types of black holes, like stellar mass black holes.
Okay.
So those come from stars collapsing. But now, try to imagine the early universe. We're talking fractions of a second after the Big Bang.
Okay. Okay.
It was incredibly dense back then and hot,
Ah.
like a crazy soup of energy and particles all smashing together.
Yeah. Wild.
The theory is that in some spots, that density was so extreme that tiny, and I mean really tiny, pockets of this primordial soup just collapsed.
Oh.
Like right then and there, they became black holes.
So instead of a giant star imploding, you've got these like little bits of the early universe just poof becoming black holes.
Exactly.
That's mind-blowing. But okay, if they formed so early on and they're so small, how could they still be around? I mean, shouldn't they have disappeared by now?
Right. That's a great question. It all comes down to something called Hawking radiation. Stephen Hawking, the physicist.
Yeah, yeah, of course.
So he theorized that black holes, they aren't actually completely black. They slowly, very slowly, leak energy and particles.
Interesting.
And the smaller the black hole, the faster it evaporates. But, and this is important, primordial black holes, they formed so long ago, they've had, well, billions of years to hang around. The smallest ones, yeah, they're gone. But anything bigger than a certain size, they could still be out there.
So we could have these ancient black holes like from the very beginning of everything, just whizzing through space as we speak.
Potentially, yeah.
That's both terrifying and awesome. Okay, but how does this connect to, the big mystery of dark matter?
Well, we know dark matter doesn't interact with light,
Right.
right? That's why we can't see it. We only know it exists because of the way it affects gravity, especially in galaxies.
Right, it's like an invisible scaffolding holding everything together.
Exactly. So now, picture this.
Huh.
Countless primordial black holes scattered throughout the universe. They have gravity, obviously, but wouldn't emit any light.
So like dark matter.
Exactly. And that's why some scientists believe that primordial black holes could actually be dark matter, or at least a big part of it.
Wow, that would be huge. It would mean that this invisible force shaping the universe is actually these tiny ancient black holes. We'd have to rewrite all the textbooks. But okay, how do you even start looking for something so small, so old, and, well, invisible?
It's incredibly difficult. One way is to search for the subtle gravitational effects these black holes would have around them. So for instance, if a primordial black hole passed in front of a distant star, its gravity, even though it's small, would bend the star's light.
So we'd see the star get brighter for a moment.
Exactly. It's called gravitational lensing. Astronomers use really powerful telescopes to watch millions of stars, and they're looking for those tiny blips in brightness. That could be a black hole passing by.
Like a cosmic magnifying glass. That's incredible. But it makes you wonder, like, if these things are potentially everywhere, could they, I don't know, pass through Earth?
Statistically, it's possible, but incredibly unlikely. Don't lose sleep over it. But this is where it gets really wild.
Okay.
There are projects like the Supercryogenic Dark Matter Search, Super CDMS for short. Right. So they use these crazy sensitive detectors very deep underground.
Okay.
And they're not looking for black holes directly, but for the vibrations, these things are called phonons, that would happen if a dark matter particle, which could be a primordial black hole, bumped into an atom in their detector.
So they're basically listening for the faintest whispers of these ancient black holes. That's remarkable.
It is. And it shows just how inventive scientists have to be to understand the universe.
Yeah.
But here's what's even more exciting. This research It's not just about finding these tiny black holes,
Hmm.
okay? It could completely change how we see the cosmos, the very fabric of reality.
It's like we're on the verge of this whole new chapter in cosmology. We've gone from the giant stars creating black holes to these tiny remnants from the Big Bang possibly being the key to dark matter, and to how the universe changes. It really makes you think, doesn't it?
It does. And think about this. What other secrets could these primordial black holes be hiding? Could they be like gateways to other universes? Could they explain gravity? We're just scratching the surface here.
This deep dive has been a wild ride. Tiny titans from the dawn of time, and they might just explain one of the biggest mysteries in the universe. It's enough to make your head spin. Thanks for exploring with us. Until next time.